Imagine for a moment that the very fabric of reality, the space-time that surrounds us, could have scars. Invisible strings thinner than a proton, yet stretching for millions of light-years across the cosmos. Structures so dense that a piece the size of a hair would weigh as much as the entire Earth. What if I told you that these bizarre entities might actually exist, traversing the universe like cosmic ghosts, leaving footprints we might be able to detect? Welcome to the surreal world of cosmic strings and exotic topological objects, where reality surpasses any science fiction you can imagine. Today, we're diving into one of the most fascinating and strange concepts in modern physics. You'll discover how defects in the very fabric of space-time might have formed in the first instance after the Big Bang, how these exotic objects could influence entire galaxies, and why scientists are hunting for their signatures across the observable universe. Prepare for a journey that will challenge everything you think you know about the structure of reality. Hello, cosmic explorers. Welcome back to Cosmic Frontiers, where we unravel the deepest mysteries of the universe. We're on an incredible journey towards our first 1,000 explorers, and each one of you makes this discovery even more special. Today, we're going to explore some of the most exotic objects theoretical physics has ever imagined. To understand cosmic strings, we first need to grasp something fundamental about the universe. It's not just an empty stage where things happen. Space-time itself is dynamic. It can bend, stretch, vibrate, and, surprisingly, it can have defects. Imagine you're observing a perfectly calm lake at dawn. The surface is smooth as a mirror, but then, a stone falls into the water and creates ripples. Now imagine that, instead of ripples that propagate and disappear, the stone created a permanent scar on the water's surface, a line of turbulence that never fades. That's basically what a cosmic string would be to the fabric of space-time. The story of cosmic strings begins with a surprising discovery in particle physics. In the 1970s, physicists realized that during the first fractions of a second after the Big Bang, when the universe was trillions of times hotter than the center of the sun, the very structure of the fundamental forces was different. It was as if all the forces we know today, gravity, electromagnetism, the strong and weak nuclear forces, were fused into a single superforce. But, as the universe expanded and cooled, this perfect unity broke, separating the forces into their current forms. Here's where the story gets really interesting. When this separation happened, it wasn't perfect. Just as when water freezes and sometimes forms imperfect crystals with flaws and stress lines, the separation of the fundamental forces could have left defects in the very fabric of reality. These defects are what we call topological objects, and cosmic strings are a specific type of these defects. But what exactly is a cosmic string? Think of a guitar string, but instead of being made of ordinary material, it's made of concentrated energy from the vacuum of space itself. And instead of being a few inches long, it can stretch for galactic distances, sometimes traversing the entire observable universe. The thickness would be microscopic, smaller than a proton, but the density would be absolutely monstrous. To give you an idea, imagine taking all the mass of the Earth and compressing it into a line thinner than a human hair. That's the level of density we're talking about. Physicist Tom Kibble was one of the first to propose the existence of these exotic structures in the 1970s. He realized that, mathematically, these topological defects were not only possible but inevitable in certain theories about the early universe. It was like discovering that the laws of physics required certain cosmic scars to exist. From this discovery, a whole generation of cosmologists began to explore the implications of these bizarre entities. Now, you might be wondering, if these strings are so thin, how could they have any observable effect? Here's the cosmic trick. Although they are incredibly thin, the extreme density of cosmic strings means they have significant gravitational effects. Einstein taught us that mass and energy curve space-time, and a cosmic string would curve the space around it in a very peculiar way. Imagine you're walking on a perfectly flat plane, and suddenly you encounter a crack in the ground. It's not a crack you can fall into, but one that creates a fold in space itself. If you walked around this crack and returned to your starting point, you would find that there was a small angular deficit, as if a wedge-shaped piece of space simply didn't exist. This is exactly what a cosmic string would do to the space-time around it. This effect has fascinating consequences. If light from a distant star passed on both sides of a cosmic string, we would see two slightly displaced images of the same star. It's as if the cosmic string were a very special gravitational lens, creating a pattern of image duplication that would be a unique signature of its presence. Astronomers have been actively searching for these peculiar patterns in the sky, using increasingly powerful telescopes to hunt for the footprints of these exotic entities. But cosmic strings are just one type of exotic topological object. There are other, even more bizarre structures predicted by theoretical physics. Magnetic monopoles, for example, would be particles with only one magnetic pole, north or south, violating our everyday experience that magnets always have two poles. It would be like finding half of a magnet that simply works on its own. Although we have never definitively detected a magnetic monopole, its existence would solve some deep puzzles in particle physics. Another fascinating type is cosmic domain walls. If cosmic strings are like one-dimensional scars in spacetime, domain walls would be two-dimensional scars, like infinitely thin sheets that divide regions of the universe with slightly different physical properties. Imagine the universe was like a gigantic mosaic, where each piece has slightly different laws of physics, and the borders between the pieces are these domain walls. Fortunately for us, most cosmological models suggest that these structures, if they existed, would have been eliminated very early in the universe's history, because a domain wall traversing the cosmos would be catastrophic for life as we know it. There are also cosmic textures, even more exotic defects, that would be like knots in the fabric of space-time. Unlike strings, which extend infinitely, textures would be compact structures, but still with detectable gravitational effects. Think of a soap bubble with a permanent knot on its surface, something that shouldn't exist but is mathematically possible under certain conditions. What makes all these topological objects even more intriguing is that they offer us a unique window into the conditions of the early universe. If we could detect a cosmic string or any other topological defect, we would literally be observing a relic from the very first moments after the Big Bang, when the fundamental forces were still organizing into their current configurations. It would be like finding a fossil not of an ancient creature, but of the very process of the cosmos's creation. The search for these exotic objects has driven the development of increasingly sophisticated observational technologies. Gravitational wave detectors, like LIGO, could potentially pick up the ripples in space-time caused by cosmic strings in motion or collision. When a cosmic string oscillates, or when two strings intersect and reconnect in a violent cosmic dance, they could send gravitational waves through the universe like ripples in a cosmic pond. Space and ground-based telescopes continuously scan the sky, looking for gravitational lensing patterns that could indicate the presence of a cosmic string. It's a meticulous search, like looking for a needle in a haystack the size of the observable universe. But the potential rewards are enormous. The detection of any exotic topological object would revolutionize our understanding of fundamental physics and cosmology. Recently, some astronomers have reported possible candidates for cosmic string signatures in observational data, although no detection has been definitively confirmed. Each new observation brings us closer to the possibility of finally finding these elusive entities. It's a humbling reminder that, even with all our advanced scientific knowledge, the universe still holds deep secrets that we've barely begun to imagine. The physics behind these topological objects forces us to confront fundamental questions about the nature of reality. If defects in spacetime can exist, it implies that the very structure of the cosmos is more flexible and dynamic than we imagined. We are not just passive observers on a static stage, but inhabitants of a universe where the stage itself can have scars, folds, and defects that tell the story of its creation. Furthermore, the study of these exotic objects connects us directly with some of the most advanced theories in modern physics, including string theory and models of extra dimensions. In some versions of string theory, for example, our three-dimensional universe could be just a brain floating in a higher dimensional space, and cosmic strings could be remnants of fundamental strings that stretched to macroscopic scales during cosmic inflation. It's fascinating to think that these objects, if they exist, are literally made of nothing but concentrated energy from the vacuum. The vacuum of space itself, which we think of as empty, actually teems with quantum energy and fluctuating fields. A cosmic string would essentially be a stable concentration of this vacuum energy, held cohesive by its own gravity in a delicate dance between force and structure. The possibility that the universe contains these exotic structures also reminds us how little we truly know about reality at its most fundamental scales. Every new discovery in particle physics and cosmology reveals additional layers of complexity and beauty in the architecture of the cosmos. Cosmic strings and other topological objects represent frontiers where our current understanding meets the unknown, places where mathematics leads us beyond what we can directly observe or experience. If these exotic entities truly exist, they would be constantly around us, invisible but subtly influencing the evolution of cosmic structures. Galaxies might have formed slightly differently in the vicinity of a cosmic string. The cosmic microwave background radiation, the echo of the Big Bang that permeates the entire universe, could carry subtle signatures of the presence of these topological defects. It's a perspective that simultaneously humbles and inspires us. Humbles because it reveals how vast the realm of the unknown that still surrounds us is. Inspires because it demonstrates the extraordinary capacity of the human mind to imagine, theorize, and search for phenomena that completely transcend our everyday experience. We are a species that evolved on a small rock orbiting a common star, but we have developed mathematical and conceptual tools powerful enough to contemplate defects in the very fabric of reality. So, the next time you look up at the night sky, remember that between you and those distant stars, an invisible cosmic string might be stretching, a primordial scar from the birth of the universe. Or perhaps, on a scale that defies imagination, there are cosmic textures and magnetic monopoles scattered throughout the cosmos as relics of an era when the very laws of physics were crystallizing into their current forms. The search for these exotic topological objects continues, driven by human curiosity and the promise that their discovery could open entirely new windows into understanding the universe. Every observation, every new theory, every experiment brings us closer to the possibility of finally finding these elusive entities and uncovering the secrets they hold about the fundamental nature of reality. We've just explored some of the most exotic and fascinating concepts in modern cosmology. We've seen how defects in the very fabric of space-time could have formed in the first instance after the Big Bang, how these topological objects could leave observable signatures in the cosmos, and how their discovery would revolutionize our understanding of fundamental physics. Cosmic strings, magnetic monopoles, domain walls, and cosmic textures remind us that the universe is far stranger and more wonderful than our everyday experience suggests. But perhaps the most inspiring aspect of this journey is how it illustrates the human capacity to imagine and seek the impossible. We're talking about structures that are thinner than atoms but stretch for galactic distances, about defects in the very fabric of reality, about cosmic scars that hold secrets from the birth of the universe, and, incredibly, we have the mathematical and observational tools to search for these exotic entities and perhaps, one day, find them. This leads us to a profound reflection on our place in the cosmos. We are beings made of stardust, inhabitants of a small planet in an ordinary galaxy, but we carry within us the capacity to contemplate structures that completely transcend our scale of existence. Our curiosity allows us to dream of defects in space-time, and our intelligence gives us the means to seek them. In a sense, we are the universe trying to understand itself, including its deepest scars and its most exotic secrets. Cosmic explorers, what mystery of the universe would you like me to explore in the next video? Perhaps wormholes and the possibility of time travel, or maybe multiverses and parallel realities. Leave your suggestions in the comments and let's continue this journey of discovery together. We're on an incredible journey towards our first 1,000 cosmic explorers. If this dive into the world of exotic topological objects expanded your horizons and sparked your curiosity about the deepest mysteries of the universe, join our crew by clicking subscribe. Every new explorer makes our community stronger and brings us closer to unraveling even more cosmic secrets. Like this video if it made you think differently about the nature of reality, and share it with someone who is also fascinated by the enigmas of the cosmos. In the next episode, we'll explore another phenomenon that challenges our understanding of physics, the mysterious primordial black holes, and how they could be the key to solving the enigma of dark matter. Until then, keep looking up and keep wondering. The universe is far stranger and more wonderful than we can imagine, and every curious glance brings us closer to understanding its deepest secrets. See you at the next cosmic frontier.